Students, just give me 1-2 minutes. In a minute, I will just grab a glass of water and then we can get started. Sorry about the delay. Am I audible already? I see some non-attentive sign. Let's see, questions, any? Okay, fine. Let me share my screen. Are you able to see my screen now? Just give a yes, no. I see only 5 attendees. Is it a good time to start? Sai Vijaya, anybody in the classroom? All online? I see very low attendance today. Can somebody give me a go ahead? Shall I start? While we are waiting for a go ahead, is it anybody from the center would like to give a thumbs up? Shall I start? Go ahead. Okay, fine. Fine. Any questions, guys, from the last sessions? Anything that you want to ask? Today we have a jam-packed agenda. We'll try to cover the indexes and the cursors. Those are the two things that we'll be targeting to cover. Dibday Prashant, you have an attentive alert high, not attentive. I don't understand what does that mean. There is a question Sai Vijaya Krishna is saying. Yes, so go ahead. Okay, fine. Now let's go back. Perfect, let's get started. So let's go back and start with the first topic that we want to cover today. Yesterday we did discuss about two aspects. One, we covered the constants, the constant or the rules that you can apply on a table, right? 6 constant type we discussed: primary key, unique key, not null, default, check, and one more. Anybody want to say? The custom constant, check, right? So all these are the constant that is available within the SQL. We also discussed about one of the aspect that when you create a primary key, by default a clustered index is created, and whenever you create a unique key, a non-clustered index is created. Okay, do remember I did discuss about it, that we will be discussing about the indexes in a separate session altogether. But do remember, the index by defaults are associated to the constant. By default, when you create a primary key, there will be one clustered index created for you in the table. When you create a non-clustered, whenever you create a Non-clustered, sorry, whenever you create a unique key, by default, a non-clustered index is created on a table. How many clustered index per table is allowed? Yesterday I explained. Anybody want to answer? How many clustered index per table is allowed? Anyone want to answer? How many primary key can be defined per table? Kalyan, right answer, one. Why one primary key can be defined on a index? Kalyan, would you like to unmute and speak about? Anybody has the answer, want to speak about? Please feel free to speak. See, student, if you have the answer, do not hesitate, talk about it. Because finally you have to appear for the interview, not me, right? So if you are clear, then you can crack it. If you are not, then it will be difficult for you. So please unmute and speak. Why one primary key can be created per table? Anyone want to answer? Kalyan is saying primary key is clustered index. Primary key is not clustered index. Primary key creates clustered index. Kalyan, be very sure about it. Primary key creates a clustered index. Primary key's purpose is to enforce rule. Its purpose is not to create clustered index. By default, it creates it. There is a reason for it. Okay. Vishnu is saying which allows only one for one table. We can define many non-clustered, but only one clustered. I'm not saying we can define many non-clustered, but one. So Sai Vijaya, would you like to unmute and talk about, please? Please feel free to unmute and speak. Can you not do that? Sai, would you like to unmute and speak? Okay, no worries. Okay, now I will repeat my statement one more time. Okay, be attentive if you have not heard it thoroughly. Do remember it is an interview question. If you are missing it now, you will miss it in the interview. That means you are giving away one question, sort question during your interviews. How many clustered index per table? How many non-clustered index per table? 999 non-clustered plus depends upon the SQL Server build, but where minimum 999 non-clustered indexes. How many clustered indexes? Only one clustered index per table. By default, because the primary key by default create one clustered index that completes the quota. By default, when you create a primary key, by default it creates a clustered index. As per SQL Server, there can be only one clustered index per table. When you create the primary key, it creates the plus clustered index. That means the clustered index quota is over for the table when you create a primary key. So by default, when you create a primary key, as your clustered index quota is complete, that's why there is only one primary key allowed in a table. Are you getting that particular reason, logical reasoning behind why one primary key per table versus many unique key per table? The reason being, by default, it creates a clustered index. Now, I will not repeat the same statement again and again. We'll move on, right? We have spoken about index so many times, but we haven't spoken about what an index is all about, right? We are saying it creates a clustered index, it creates a non-clustered index. Repeatedly, I'm saying it. But let us understand what do you mean by a clustered index and a non-clustered index. Guys, have you seen the index page of a book? Let me try to grab some images. Have you seen this diagram ever? Let me try to drag it to this side. Have you seen this particular diagram ever? Have you seen the book images like this? Books index pages where there will be an introduction, there will be some essential, getting started, cameras, lenses, there will be some content written, and there is a page number associated to that particular book's first side of the page. Did you see that ever while you are studying? You must have seen it, right? When you are doing your engineering studies, your masters, your non-technical BA bachelor's or anything that education that you have come from, every book contains this in this page known as contents and indexes page on the start page of the book. And if you have thoroughly read your book, there are indexes also available in the back side of the book. If you have not seen it, please, if you are there at home, grab a book and see. You must have two categories of index pages available in your book. One, when you open the book, then you see this contents and index block. And when you go to the back side of the book, you will also see, if it is a good thick textbook, then you will definitely see those index pages on the back side of the book, alphabetically sorted. There will be words, and then there will be a page number associated to those words, or there will be a reference of a specific word, and it will be written, this word can be found in page number 2, 3, 7, like that. Is that understanding correct? Can I get a yes no kind of answer? Have you seen those kind of things or not? Have you all seen those kind of things in the book, the index pages and the there are two categories of index pages. Okay, let me talk about how human has designed or came up with the concept of clustered index versus a non-clustered index. Do you remember when you open the book, there is a chapter number, there is a sub chapter number, and exactly the page number is written for that, right? A bullet, a page reference number, there will be article number, and for that particular article it will say that if it is a mathematical book, where is your Pythagoras algorithm is written, page number 37. Where is your trigonometric equations are written, page number 97. Where are your circle and circle or squares perimeter rules are written, right? Page number 175, right? That is how the definition of a exact subcategory, subheader, and a exact specific page number is written. Do remember. Think about this. You are holding a book. Imagine this. If you have a book, then you can actually open the book, and whatever I'm saying, you can do it. If you do not have a book, then at least try and imagine this. You are holding a book of 1,000 page. Okay, it's a big book. It's a big, thick book. Now I am asking, can you tell me where can it is a chemistry book? Let's say, for an example, I'm just giving an example. It is in physics or a chemistry book. I am asking, can you tell me where is the Bernoulli's formula is written? My question is, where is the Bernoulli's formula is written? What would you do to find that? Can anybody unmute? We are just talking about theory here. I'm talking about theory because this particular concept needs understanding. That is where we are spending time in discussion, because explaining is pretty easy. I will show you the command syntaxes are only two. So it is not about command syntax. It is all about understanding the basics. Okay. Please feel free, unmute yourself and speak about, please. I would encourage you to speak, please. I can read it out, but I would encourage to unmute and speak. Go to the back of the book. Krishna is saying, go to the back of the book, check the page number. By seeing topic in the content. Kalyan, by seeing topic in the content. That is the right thing. What you would do, you will go to the content page, you will scan through. Where is the Bernoulli's theorem? Whether there is a rule called as Bernoulli's theorem written in the content and index pages. Okay, good approach. Sai Vijay is saying, yes, we have seen. Kalyani is saying that. Now Krishna is saying, go back to the book and check the page number. Where would you check the page number, Krishna? Go go to the back of the book and check the page number. Yes, that is correct. You can look for the keyword B, and for the B category, you might find Bernoulli's theorem. And in the Bernoulli's theorem, the page reference also you can find page number 25, page number 135, page number 139. That is another approach. If you are going to the back of the book, you might find three references. If you go to the front of the book, you will find only one reference. Okay. Are you guys not able to unmute yourself? Any problem with unmuting? Can somebody try unmuting? Guljar, would you like to unmute yourself and please speak? For I want to just see the testing, because I was given a confirmation if you can unmute yourself. Guljar, would you like to unmute and speak, please? Guljar, Kalyan, anybody feel free, unmute, and I just cannot mute by ourselves. Can you? Yeah, now it is. Kalyan, can you just tell me what would be your approach? I said find out the Bernoulli's theorem. You are unmute, Kalyan. You can say now.
By seeing the topic in the contents in the first place, like which topic it is.
Which topic you are trying to look for, that you will do,
Yes,
right?
Yes, yes,
You
sir.
might find it, you might not find it. What would you do then? You
Actually,
might find that Bernoulli's theorem written in the content page or back up the content page. It might
no, sir.
not be there.
Actually,
What would you do?
Bernoulli's theorem is not written in content space, but the subtopic is written actually, to which Bernoulli's theorem belongs to some topic.
Maybe
So
some
should
subtopic will be there. I think Bernoulli's theorem somewhere related to the pressure, right? And it is
yes, sir.
related to the liquid pressure, right?
Yes,
We
sir.
can actually
Yes, sir.
categorize them and then we can go for the subcategory of the searching. Is that understanding correct?
Yes, sir.
If the Bernoulli's theorem is not written, at least I will try to identify the subcategory where this particular formula belongs to. If I know, if I don't know, my approach will change, right? I know Bernoulli's theorem is related to the pressure and it is related to the liquid pressure. So I will go and find out which are the subject that is talking about the liquid pressure, and then you will start searching. That is one way of searching. What is coming to your mind if you have studied engineering? You will find books in the library where the content page and index pages are all gone. You must have encountered one or the other book where that particular thing has happened, right? If your book doesn't have an index page, what would you do, Kalyan? Kalyan or anybody want to speak up? Unmute and speak, please. Two things will achieve. One, I'm not trying to get an answer. You will feel free to speak up in public forum, right? That is the confidence that you will get that I can speak now, right? So feel free and speak. Unmute and speak. Anybody want to speak? Maybe I will pick and choose. Maybe Manideep. Manideep, would you like to unmute and speak, please? What would you do if your index pages are not there in the book?
It is difficult to find out the content, sir.
But what would you do? You don't have that index page. Some
We,
genuine genius guy came out and tear up the index pages from the book. What would you do to find out Bernoulli's theorem?
we go through the pages, sir, thoroughly.
You will go through all the pages to find out. Is that understanding correct? There is no other way to find it out. You have to look for each of the page to find out where is the mention of a Bernoulli's theorem. Is that understanding correct?
Yes, sir.
That is one way. Can you do some another way? A lucky guy can also do. You must have played the page number book, right? Somebody ask you to open up a page number. He will say that if you open a page number between 1 to 100, you win. If you randomly open a page and you open the page number between 1 to 100, you win, right? Or you open a page randomly between 200 to 300, then you win. You must have played that particular game during your childhood, correct? There is another approach, brute force. What would you do? If you're lucky, what would you do? You'll just randomly open and scan through. Okay, let me open up 100 page, let me open up 12. And if you're lucky enough, within 2, 3 scans, you might be able to find it, Bernoulli's theorem, in some mention. If you're lucky enough. If not, you will be just randomly searching it out. And finally, what will happen? You will end up searching each of the page. Is that understanding also correct? That is another approach. You will do a random search. If you cannot find, then you will go by one approach. That is the logical way of searching through the pages. Why I am talking about this story? Do remember the way human will search, the same way human has designed to search in the SQL Server or any database programming concepts. Okay, we have spoken about three things. One, a book. We have spoken about and search topic known as Bernoulli's theorem. We are talking about either the topic is listed in the index content and index page, or it is available in the backside of the book known as summary and index page, right? There are three possibility that this particular index page is available in the book. If somebody asks me to go look for the Bernoulli's theorem, I will predominantly come to the content and index page, look for Bernoulli's theorem. If I find it, then I will look for the page number, directly open the page number. That is the fastest way of finding it. Second approach, I didn't find a Bernoulli's theorem in the content side. I will change my book direction. I will go to the last page of the book. I will try to look for the summary and indexes segment where there will be alphabetically sorted important words of the book and the occurrences of the page number where this particular word can be found, right? If you have not done it, I would recommend please go and open any book today after the session just to memorize the concept. If you memorize this concept, you are really sorted for your life. Remember, if you understand this analogy well, You understand the clustered, non-clustered, heap, everything well. Okay. Remember about the book and the problem statement that I'm talking about right now. If you what would you do? You will go to the back side of the book. You will open up the page numbers, and sorry, you will look for the alphabetically sorted word. You will look for Bernoulli's theorem. So we'll go for the word B. You will see Bernoulli's theorem is possibility of finding the Bernoulli theorem is in the page number 75, 135, 290. I'm talking about a random number page. So I will go and check for those 3 pages to see whether Bernoulli's theorem is used or the Bernoulli's theorem is described there, right? So out of these 3 pages, there will be one page where I can find the entire rule for the Bernoulli's theorem, and then I am sorted. If I am that unlucky guy where the book does not have a content and index page and summary and index page, both of the index pages are missing from the front side of the book and the back side of the book, then what I am going to do is I'm going to scan through the book, right? I can do 2 way of scanning. If I will try my luck first, I will randomly just scroll through the book, right? Page number 10, 15, 75, 85, 90, 130. I will randomly look through. If nothing works for maybe 5, 6 attempts, I would do what? I would go by page to find out where the possibility of Bernoulli's theorem is there. Does anybody has any other approach to find it out? If you have, please feel free. Let me know your name. I would unmute you. Anybody who has any other approach to find the Bernoulli's theorem in the book, the theoretical question that we are trying to attempt, other than these 3, do you have any other approach to find it out? You will have another approach. You will go to the Google and ask, tell me the book name and where can I find the Bernoulli's theorem, and then you will find the page number and come back and look for the page number. I'm not talking about that. I'm talking about in reality in the physical form. What would you do? There is no other way. These are the 3 or 4 possible way to figure out the data inside a book. Exactly similar way SQL Server has designed its searching pattern. Do remember, indexes helps in searching the data stored inside a table in a faster and efficient manner. Why do you need an index? Index helps in searching the data that is stored in a table in an efficient manner. Finally, the data inside a table is stored on a storage area. Think about this and listen very carefully, student. Today's topic is interviewer's favorite, and it is very, very important from your day in, day out engineering concepts also, right? Index plays a very, very vital role to speed up your query performance. So please pay attention to every line of statement that I'm mentioning today. If you miss any concept, I would still encourage go back and go through the entire recording one more time today. Okay, this is very important concept, and in every interview you'll go, you will find 2 interview questions from this particular segment, bare minimum 2. If you are going for a SQL specific engineering discussion, going for data analytics engineering interviews, you are going for data engineering interviews, you will find at least 2 questions from this. Okay, now one question: what is index? What is the purpose of index? What value it brings in? Index is a database object that allows you to look for the data records inside the storage area in a faster and efficient manner. That is what an index is. Index is a database object that helps you search for the data stored inside a table in a faster and efficient manner. If I say the statement that way, let me understand how the data inside the table gets stored. Whatever data I'm writing in English or Germany or Japanese or Chinese, whatever character I know, if I write that particular statement or whatever data I store, finally it gets translated into bits and bytes. Whenever I say insert into table ID, first name Rahul and Dravid, do you see that data is getting stored as Rahul and Dravid? Absolutely not. Rahul and Dravid are getting converted into zeros and one, and then those zeros and one are getting stored in a storage area. Because you have installed the SQL on your own laptop or a desktop, the data is getting stored on the hard drive of that local machine. Try to understand that particular concept. Data is getting stored on the storage area. When I say storage area, the storage area can be, if you are using a local machine, then that is the storage area can be two path. One, the hard path. Hard path means what? Where your actual data will be persisted for permanent storage. That is your hard drive. There is the temporary path. When you declare a variable at the rate sign or hash, those are temporary objects, right? When you are using any temporary objects, the data will be stored in the memory. There are two components inside your computer system. One is the memory, that you say my memory is 6 GB, 8 GB, 16 GB RAM, 32 GB RAM. I have a very high performing computer. Your RAM, the random access memory that you talk about, that is the temporary storage. You have a physical storage. Physical storage can be 1 TB. If you have using SSDs nowadays, SSDs come with 256 GB hard drive or 1 TB worth of hard drive and space, right? Or 2 TB, whatever is your configuration. That is your physical storage. The data finally gets converted into zeros and one, gets stored on the hard drive. Okay. If it is a variable like table variable or a time table, it goes into the memory area, gets stored for a temporary duration, and then get destroyed. Now, talking about when I have millions of record stored in a table, the data gets logically stored in a table, but finally they get converted into binary zeros and one, goes and saved in random areas within the storage drive, that is your hard drives. How the SQL server will try to find those data when you write a select star from employee table having 10 lakh rows, find out whose name is, first name is Raparthi and last name is Manideep. In that particular thing I have to find out, how do I find out, right? When you write this particular query, SQL server translates the code into zeros and one, it sends it to the engine tries to go and search for the entire hard drive to figure out where is the data available whose name is, first name is Raparthi and Manideep. When it will try to search, think what human would have done. If I have some index page available, contents and index page available, I would first go and look for the content called as whose first name is Raparthi and last name is Manideep in the content and index page. Is that correct? Bernoulli's theorem I am looking for. If I can find it in the index page, I will find the page number where it can be found. I will go exactly to the page number, get the data and come back and display to the user. That is one approach. Second approach, I didn't find the exact page number in the content and index page. I will go to the back of the book. There is another kind of index available known as summary and index page. I will try to figure out whether any word known as Raparthi available that has an index available. Yes, I found there is a Raparthi first name. There are 100 record, and Manideep first name, last name. There are 200 record. Okay, rather than searching 1 million rows, that is 10 lakh rows, why don't I search only 300 rows? There are Raparthi with last name 100 rows, Manideep with first name 200 rows, total 300 rows. Let me figure out where exactly the last name and first name matches Raparthi and Manideep, right? If I can do that, then my search area is lessen and my searching will be much more faster. That is the second way of doing it. Third way, I don't have a content page. I don't have a summary and index page. I don't have any other option than to go and scan through each of the record for the corresponding employee table to find out, tell me out of this 10 million rows, I will go and look for all the 10 million rows to find out for every row of data stored on my hard drive, tell me wherever the first name matches Raparthi and wherever the last name matches Manideep. These are the three possible way of searching the data. The first way of searching the data is known as clustered index, where I have the exact definition of my word and its exact page number is stored in some area. known as index allocation map. IAM, index allocation map. Take a note of it. If I can find the exact word and the page number where the word is stored, if it is available, then it is the clustered index. If I don't know the exact location, but I may find a relative location, the word Bernoulli, Bernoulli is available in this book and 3 occurrences in the page. One is page number 35, one is page number 75, one is page number 95. If I find a relative path, not exact but relative, then that kind of indexes are known as non-clustered indexes. The third category, a table that does not have a clustered index, is known as a heap table. Okay, when you write a select query on a table that does not have a clustered index, the type of search that will happen is known as a table scan. When you scan a table without an index or without a clustered index, you will say that I'm searching a heap table, and the type of search I'm doing is table scan. Table scan means what? I don't have the front of the content page is available. That content page, some intelligent student has tear it off from the book, and summary page also the same intelligent student has taken it out, right? What is left is the book with the content. Now you search through each of the page, right? Page by page. That is known as the table scan. I will take a pause here, okay? I will take a pause here. Before going into the concept more further, I want to ask, did you understand the 3 concepts at least? There are 3 types of possibility to search through the data. One, with the exact data and the page number available. Other, relative path of the data and the page numbers. Third, there is no page number, I have to look for the entire data. These are the only 3 possible way. When I don't have the page number, I have to search through the data. Easy thing, table scan. Scan the entire table. If I have the exact path of the page number and the data available, clustered index. If I have the relative path and the page number available, non-clustered index. Clear about that concept? Can I get a yes, no, please? Or if you want to ask any question, I see question from Vijaya, Kalyan. Kalyan, would you like to go unmute and ask? Kalyan, you have any question? Or Sasi Vijaya, Sasi Pritam, you have some question, but would you like to unmute and speak, please? Am I getting it wrong? It is like I cannot unmute. Kalyan is saying again I cannot unmute. But I don't have any. It is saying self-muted. When I go, can you just try unmute one more time? Yeah, you are able to.
So, in the unclustered index, you mean the relative path and the page number you are telling, is that the exact page number or some random page numbers?
It will be exact page number of probability of finding that same word where it is available. Have you read a book ever?
Yes, sir.
You are from engineering background. You are from non-engineering background.
Engineering backgrounds.
Engineering background. In any of your engineering book, you must have seen your pages, right? Index page
Yes, sir.
and summary and
Yes, sir.
synopsis page. When you
Yes, sir.
go to any of the page, do you see that there will be a chapter listed? The chapter can be found is page number 35, but when you go
Yes, sir.
open page number chapter 35, you will find some random topic. Have you
Yes,
ever
sir.
seen that?
Yes, sir. Beginning of the topic.
That never happened, right? When it is mentioned, that means a proper record is mentioned and captured somewhere. Is that correct?
Yes, sir.
Okay. Any other question, Kalyan?
Yes, sir.
Okay, fine. So now let us proceed further. I am there on this particular slide since half an hour. Now let us talk about what the index is. Okay, very short and crisp. Whatever explanation that I did, I will just summarize now. An index is an index is a disk structure associated with a table or view that speeds up retrieval of the rows from the table or view. Okay, do remember, index are associated. You should create index on a table when you want to select your data in a faster and efficient manner. Do remember, indexes helps optimize the query retrieval operation. We can do 3 operations. Is that correct? Store, retrieve, manipulate. Storing is create inserts. Manipulations are DML, insert, update, delete. Retrievals are select query. Indexes are very much associated with the select queries. Okay, indexes are meant for the select query. There are millions and billions of rows available, and how fast you can search the data from the table. You run a query and you are sitting for 10 minutes to find the data, versus you run a query and within nanosecond you are getting the data. That is what the difference our index creates. Okay, if you don't have an index, your query searching will take a lot of time, because it is going to go for a table scan. You have an index available, it will look for the data from the index and then try to fetch the data. Okay, do remember this particular area. The index in SQL Server, the data type used to store the index data is known as B tree, binary tree or B tree. Okay, binary tree is a tree where if you are coming from again the computer science engineering background, do remember binary tree means what? There is a parent and there are two child. That is binary child. Binary means two. Every parent has two child and every subsequent child has two childs further. That is what the binary tree is. But a B tree is a balanced tree. Balanced tree means what? Balanced tree are, you can have indefinite childs, but it is balanced in a manner. Okay, I would not go into the definition of B tree. It has no relation with the SQL Server. It is a data structure used in SQL Server to store the index data. If you want to learn more, go and study about the B tree, a balanced tree. What is the B tree? What is the binary search tree, binary sort tree? I would encourage read fundamental of the algorithm. Right? It has nothing to do with the SQL. But if you want to derive more concept, understand what the B tree is all about. Okay. I will show you one example that will give you some more clarity. A B tree in SQL Server look like this. There is a top row, then the top row is splitted into three parts. Then each of the split has again further splits. Can you see in the second, in this particular diagram, the top row is the index row here. Then there are three split of the index rows. If you see the middle index is again splitted into multiple 5 sub indexes. That is how a B tree looks like. A tree underneath the tree is a B tree. Okay. Do remember that there is also an interview question. What kind of data structure is used in storing the data inside SQL Server? The data structure is B tree. Okay, balanced tree. Now let us go to understand how many types of indexes available. There are only two types of indexes available in SQL Server. One is known as a clustered index, other is known as a non-clustered index. What is a clustered index versus a non-clustered index? Do remember, when you go to the index page of your book or the content page or the front side of the index page of the book, the exact chapter number and the page number are written in a sorted manner. Can you see that? Chapter 1, page number 1, chapter 2, page number 25, chapter 3, page number 35. They are all listed in a sorted order, right? It will start with the page number 1, it will end with the book's last page. That is how the chapter is defined in the index page or the content and index segment of the index side. That we call as a clustered index. Why? Because it is written in a sorted manner. Okay. Clustered indexes sort and store the data rows in a table or a view based on their key values. I will talk about the key value, forget about it. Do remember, clustered index sort the data. That is the definition that you should remember. Take a note also. If you have a pen and paper, please write it down. Towards the end, if you have doubts, we'll discuss. We have a 2-hour session today, so we'll spend quality time on this. Clustered index sorts the data. This column, I have actually taken this definition from Microsoft site itself. The same exact definition you can find on the Microsoft MSDN site also. Okay. These are the column included in the index definition. There can be only one clustered index per table. I'm highlighting this particular thing. It is a rule for SQL Server. There can be only one clustered index per table because the data rows themselves can be sorted in one order. Do remember. What does this particular line mean? Why you can have only one clustered index? There can be one question, right? What is the, if I can increase my clustered index, I can have many primary key. Somebody can ask the same question. You are saying there can be only one primary key because when you create a primary key, it creates a clustered index. I have a rule in SQL Server that there can be only one clustered index per table. But can I create two clustered index somewhere? Absolutely not. Why? Because when you create a clustered index, it creates a sorting pattern of the data for you. The column on which you will create a clustered index, that particular column defines the sorting pattern of the data for the entire table. You cannot have two columns defining your sorting pattern for the data. We are not talking about order by clause here. We are talking about how do you store the data. While storing the data, I have to either think about this. Either I will say the chapter 1 starts with page number 1, or I will say my book page number, my last chapter, I will say there will be one pattern, right? In the content and index segment, either I will say that I will write my chapter number 1 first and my chapter number 10 last. That will be one sorting pattern. Or I can say, I will say chapter number 10 first and chapter number 1 last, right? Typically, you have only one option. You are saying my chapter number and my page number. I am talking about one column and the availability of the data in that particular column. You can only choose one or a combination of one column to create that particular primary key or the clustered index, but that only column defines the sorting pattern of the data within the column. If you do not understand, don't bother. I would say again and again, if you don't understand, don't bother. You will understand it when I will actually show example. Do remember this line, okay? Highlight. There can be only one clustered index per table, and the reason being because these data rows themselves can be sorted in only one order, okay? Either in ascending order or a descending order, okay? The only time the data rows in a table are sorted in the time when, the only time the data rows in a table are sorted in sorted order is when the table contains a clustered index. When a table has a clustered index, the table is called a clustered table. If the table has no clustered index and data rows are stored in an unordered manner, it is called as a heap. Do remember, this is also an interview question. What do you mean by heap? Heap is a table that does not have a clustered index on them. Do remember, one interview question, 3 interview question only we have discussed by far by over discussing this. First question, what is index? Index is a database object that helps in retrieving the data from the database faster. That is the definition. How many types of indexes? Clustered and non-clustered. What is the behavior of a clustered index? When you create a clustered index, by default it sorts the data. Sorting can be done in how many pattern? 2 pattern, either ascending order or descending order. How many columns can be involved in deciding a clustered index? There can be many columns involved in deciding the clustered index, right? But there can be only one clustered index. If a table does not have a clustered index, what type of table it is known as? It is known as the heap table. Clear up to these 4 or 5 interview question? Now, let's proceed to the non-clustered index. Non-clustered index have a structure separate from the data rows. Non-clustered index contain non-clustered index key and value store, like the book in the summary side. The pointer from index row, the pointer from an index row in a non-clustered index to a data row is called as a row locator. I have given a definition for this particular thing. You can read it, okay? Do remember, non-clustered index does not store the data. I will show you the data, but read through. It is only for your understanding sake. Do remember, clustered index sort the data, non-clustered index does not sort the data. That is the only thing that you should remember for the timing. Take a note, clustered index sorts the data, non-clustered index does not sort the data physically, okay? Non-clustered index does not sort the data physically. Sorting, I'm talking about sorting, not searching, okay? We have seen this particular behavior. We have already spoken about it yesterday. I'm just writing it for your references. By default, when you create a primary key, we have seen a clustered index being formed yesterday. Whenever we create a unique key, we have seen a non-clustered index being formed yesterday. We have seen this particular behavior. Can you see that? In the indexes, when we are creating a primary key, can you see I have given a naming convention. PK means primary key. Whenever I have created a primary key, by default, a clustered index is created, correct? Let me go back and do a refresh. If I do have a, I don't have a unique key, maybe I have created on the employer department table somewhere I created. I do have a non-clustered index definition. Yeah, we have created this particular employee table. I can create this out, right? Alter table employee and add constraint this. We have done that. So let us do this. I'll just do this. Yeah, duplicate keys found. So some duplicate record are already there. So we'll see that. We'll see through the example today. We'll create some indexes and we'll see that. Whenever you create an unique index, a unique constraint, by default and non-clustered index is formed, right? That is what the definition is written and you can read through. Now, the structure of an index. Do you remember how the index starts? The data record when first gets inserted, the row ID will be 1. Okay, the row ID 1. So it will say my row ID 1 is splitted here. Now between 1 to 100 row, it will sort the data, right? Typically, do remember, this is also an interview question. What should be the data type that you are choosing for your clustered index or a primary key? I'm repeating the question again. What is the best type of data that you should choose for your primary key constraint? Can somebody want to unmute or write down the answer if you are aware, or if you think what type of data is a good data? Numeric data, string data, datetime data. What is the good data for your primary key constraint? People have dropped out. I saw 13, now only 10. Numeric. Somebody is saying integer. Bijay is saying integer. Sai Bijay is saying numeric. Srinivas is saying numeric. That is right answer. You should choose numeric type of data for your primary key constants. Okay. The reason being, numeric are unique in nature. 1, 2, 3, 4, 5 are unique in nature. That means you can actually enforce a proper unique value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. That is where the data comes with the the right choice of data for choosing a primary key value is a numeric type of data. I'm saying numeric. It may be integer, big integer, decimal. What type of data you are going to choose, it doesn't matter. But numeric is the best choice. Now, what SQL Server does internally? Say for an example, a data row between 1 to every data row that comes with an ID. What it will do? It will sort them. First, what row is coming? Somebody is trying to insert an ID 1. Okay. Somebody is trying to insert an ID value 100. Okay. Somebody is trying to insert an ID value of 25. Okay. Now I know first record is 1. That is, I can find out it is the first in the sequence. Then somebody inserted 100. Okay. I will keep it. Now somebody inserted a 25. Now 25 is coming in between 1 and 100. Okay. Let me sort it. Then what I will do? First I will do 1. Then I will swap. Can you see these images of swapping? Arrow going from here to there, then coming here to here? That means data swapping is happening. SQL Server is internally doing the data swap, because every row while getting inserted, it will identify what value you are trying to insert, and it will arrange the value depending upon the way it is getting inserted. So 25 came in between, so it will swap second record to be 25 versus the third record to be 100. Now a data row came 75, right? It will swap. Now the fourth record becomes 75 and 100 becomes the fifth row, right? This is how the swapping will happen. This is what the typical structure is. And there is another example that cites the same thing. There is a ID, there is a page number. Initially, the page number 123 represents 1 to 50 data is in the page number 1, 51 to 60 in the page number 2, 61 to 80 in the page number 3. Somebody inserted some more value. Say for an example, query came, get me the data, select the data where the ID in 35. So now SQL Server knows the data row ID between 1 to 50 is available in the page number 1. Rather than going and searching for the entire pages of the book where it is going to fetch, it will go to the page number 1 to fetch it, because it knows the data row between ID 1 to 50 is available in the page number 1. Rather than searching everywhere, it now know where to search the data. When the record came, select star from the table employee where ID equal to 55. Okay, 55 is within the range of 51 to 60, page number 2. I will go and search the data in the page number 2. This is how the indexes work, or this is how SQL Server works. Now, create indexes. How do you create index? Okay, I will show you the pattern. Yesterday we have seen by creating the primary key by default, you can create an index. We have seen that structure. Now we'll see another structure. Okay, what do? You want to create a clustered index, go to the object explorer. You know the object explorer here. This is known as object explorer. Okay, this side of the thing. If you see the highlighted area of my cursor, it is showing the object explorer on the top. Okay, go to the object explorer. What it is saying, if you want to create a clustered index, right click in the index folder. You want to go and create a clustered index. Say for an example, what is my I want to create a clustered index on my pet table. Say for an example, I want to create a clustered index on my pet table. I will first have to choose a clustered index on my pet column. This is first thing, it is a very inappropriate data to create a clustered index. The reason being, I should choose a numeric data to create a clustered index. I'm choosing a varchar, which is fine if it has to have a unique value. If it is having unique value, still I can create a clustered index. If you are choosing a varchar value to be a clustered index, it is okay, but it is not giving you, it is not going to give you that much of performance if you had chosen a integer type of data. The searching operation is much more faster on a numeric data versus a varchar type of data. Okay, go to the column. I will go to the indexes here. I will go to the indexes, right click on that. I will say new index. Can you see that? What I'm going to do, go to the right click, indexes, new index, clustered index or non-clustered index. Can you see that? Don't think about this cluster column store and non-cluster column store. I will talk about it in a different session altogether. Clustered index and non-clustered index are the primary index that you can create. Okay. When you create the, I'm hitting the clustered index now. Okay. It will open up the wizard. What it is saying, by default, see, it is choosing the index name for you. You can change the index name. I will say index name would be IDX. That is an industry name. Either you will say IX stands for index or IDX. Okay. Index name is IDX underscore. I will say the table name is pets. I will say on which column I want to create the index. Okay. I will add a column that I want to add to select from which column I want to create index on. I am choosing pet ID to be my index column. I'm selecting that pet ID which is to be index column. Can you see that? Pet ID. So I will give the name. I'm creating an index IDX pets pet ID. Pet ID. Okay. Okay. Just see what happens. In your machine, it might be faster. In my machine, it is slower. I do have a lot of applications running that makes it pretty slow. If you're trying to do right now, you can also do it. Okay. Right click on the index, new index, clustered index. Can you see that I am able to create a clustered index here, right? This is one way of creating. There is another way of creating. How do you do that? Okay, index column on the clustered index. Now, create another index keys, create a, yeah, this is one way. There is another way. While creating, you can also choose. Okay, let us see. This is an existing table on which I created a clustered index. Okay. How about going to the product table or products table or student 2021 table, and I want to create an index over there. I will right click on that. I will go to the design. Okay, there is a table that does have a name and total mark available. Let us see how do I create an index on that. It is still fetching the data. Just allow it to complete. Yeah, now it is there. So I will go to the click on the index or keys table designer, click on index keys and click add. It is not allowing to do that, but you can do here. Say for an example, I want to do it. Can you see this? Right click on this particular row. Say for an example, I want to create an index on the name column. Right click on it. Do the index and keys. Then you have to say add. Then I will say by default a name is created for you. Can you see that? Name is IDX student 2021. And then you are saying this is the column on which I want to create an index. Okay. Type is index and create as clustered. Either you choose yes or no. If you say it is a, I want to create it as a clustered index, yes, then it will create it as a clustered index. Okay, I am choosing clustered index, yes, and then I would say close, and then I will save the design. Save the design, Control S. I'm saving the design. Okay, I will go to the student 2021 table now. Go to the indexes. Can you see this clustered index created another way? I student 21 and a clustered index is created. Any question by far? How do you create clustered index? Either you can open up the table designer, choose the index segment. I will show you one more time. We created a clustered index. Now I will again go to the design. Right click on the row on which you want to create the index. Say for an example, I want to create the index on the total mark now. In a hung state. If you have SQL Server, please try it out with me alongside so that you understand what I'm trying to do. Right click on it, index and keys. Create it as a clustered index or non-clustered index. Already I have a clustered index. Let me try to create it as a clustered index one more time. Let's see what happens. I'm trying to save it. Let's see, index, refresh. It didn't create. Even if I did choose, it did not create it because already a clustered index is there. Okay, I'm doing one more time. Going to the design, went to the total mark, right click on it, index and keys. I'm saying you choose it to be a non-clustered index now. And I will say add it. And I will say choose it as a non-clustered index and close it. Then I will save it. I will come back to the indexes, right click, refresh. There is a non-clustered index created. Okay, this is the first index non-clustered because I chose the other to be clustered, so automatically it made the previous one was non-clustered, right? Don't get confused by that. I will just delete it for the sake of understanding, because I was doing that operation of choosing the other as a non-clustered index, so it automatically translated the previous one to be non-clustered, because as per the table design only one can be a clustered index. Okay, so this is another way of creating the index. But most importantly, are you going to create the index this way? Never. I'm showing you these are the possible option, but the way you should actually do your index creation is by this method. Okay, is your query. How do you create the clustered index? Say for an example, this is my table, create a test table. I'm creating this particular table. Okay, I'm creating a test table. Column 1, column 2, column 3. One is the integer column, one is the character column, one is the variable character column. Okay, see, there is another form that I have introduced, nchar, nvarchar. Okay, char means, I have spoken about it, char means a dedicated space, varchar means a variable character space. Okay, nchar is alphanumeric characters. You can store alphanumeric. That means you are giving an instruction. Might be saving at the rate, I might be saving ampersand, I might be saving crate, whatever a symbol, extra special character I want to also save. Same for this one. Okay, I have created a table, 3 column integer char varchar. I want to create a clustered index on my column 1. Okay, this is what I want to do. How do I do? Create clustered index name on table name bracket on which column I want to create my clustered index. I'm repeating one more time. How do I create a clustered index? Create clustered index. Then I will say index name on. I'm saying create is the keyword, that is the command I have studied during my DDL session. Create is used to create any kind of objects on the database. Create structure says create object type, object name. So I'm saying object type is this, object name is this. Are you getting that? Up to this point nothing changes. Create object type, object name. Create clustered index is the object type and object name is this one. Create table, table name. Create view, view name. Create clustered index and index name. There is nothing, but the optional structure that you see is here. What? Create the cluster index, but on where? On the table, test table that I am creating here. And on which column? The test column 1 is the column on which I want to create the clustered index on. Okay. I will not create the index yet. I have created a table called as test table. Let us first see the table definition. Refresh. Can you see this test table? Let's go to the indexes. There is no index. Can you see? There is no index at all. Let us do one thing. Let us insert some rows into the table. Column 1 is the integer column, so I will insert 1. Test column 2 is the varchar. I will say Sachin. I will say last column as Tendulkar. Okay. I will repeat this statement 3-4 times. So be with me here. It is a very important topic to understand. Now you will see the behavior. What is the difference between them? Okay. Now I am inserting a record 12. I am saying my 12th man is Venkatesh Prasad. I will say my 4th down is Rahul Dravid. So I have left watching cricket. So I am into that era of the players that I know of. So please pardon me on that. I will say the second down is maybe I would say who is Kohli, Virat Kohli. I will say third is I don't know who. Third would be, say for an example, who is KL Rahul? KL Rahul. Maybe I will ask my 5th batsman to be Mahinder Dhoni. Okay, I'm just trying to insert some garbage, random records. Okay, in the test table, I'm inserting a few rows of data. Just see, I'm just trying to insert this 5 rows of data. There is nothing interesting by far. I said index is very much related to the searching behavior. Okay, now I am writing a select star from test table. I don't have an index created on the table yet. Do you remember? I haven't created any index in the table. I'm doing a select star from the table. What is the data looking like? First row 1 came, second row 12, fourth row, third row 4th, fourth row 2. Can you see that? Fourth row 2. The way I inserted the data is coming out the similar way. Is that correct? Fifth row KL Rahul and fifth row Mahinder Dhoni. Clear up to this point? The way I inserted the data, the similar way the data came. First record being Sachin, second record being Venkatesh Prasad, third record being Rahul Dravid, Virat Kohli, or this is the sequence I inserted. Now let us see the behavior. What did I say? If I create a clustered index on the table, the data will be sorted automatically for me. Let us understand. Do you remember? This is the column, test column 1, where the sequence is provided. Is that correct? This is the sequence order. Batting is Sachin Tendulkar coming first. Virat Kohli will open with him. KL Rahul will come with the third down. Rahul Dravid will come with 4th down. Mahinder Singh will 5th down. I don't have the sequence after that. Okay, this is the column that contains the sequence of them. Now I want to create a clustered index on the test column 1. Can you see that? Create a clustered index known as IX or IDX. Anything works. I would prefer IDX. Test table is the table name. The column name on which I want to create the index. This is the way you should name the indexes. IDX for index, on which table, underscore the table name, underscore the column name. On clause to say on which table you are trying to create. On the test table. Then specify the column on which you want to create the index. Bracketed the column name. Test column 1 is the column name. Column name is test column 1. Okay. On that column, I am creating the index. Let's create it. I have created an index. Okay. By far, the index was not there. I'm doing a refresh. Can you see on my index, there is an index created now, clustered index created. I'm going to do the same select query. What happened here? See the behavior change. Did I write order by clause? I am not writing order by clause. Just a while ago, before creating the index, it was showing me the data in a different order. What it was showing? Sachin Tendulkar 1, Venkatesh Prasad 2. The way I inserted it was displaying the record in the similar way. First record Sachin, second Venkatesh, third Rahul, fourth Virat, fifth KL, and sixth Mahinder. Now the entire sequence is changed. Why? Because I have created a clustered index on the table. And on the column on which I created the cluster index, by default, it sorts the data in that particular column and created the storage for us to retrieve the data. Okay, that is the behavior that a clustered index brings onto the table. Also, do remember, this is also an index. This is also a behavior that I should have actually spoken about it. Okay, till now, any question? Are you clear about the clustered index concept?
Sir,
Anybody want to ask a question? Kalyan, go ahead.
sir, you have created cluster index for test column one, which is in alphabetic numeric order. So it is the output regarding to the numeric order. What if we create the cluster index to test column two, which is in the alphabetical order? You said that we can
If
create
I
test.
create a clustered index on the test column 2, you tell me what will happen. Will it create or will it not create?
It will create because you said that it will create if the values are unique actually. The
It
data
will
is unique.
create and it will create and sort it in the alphabetical order. Correct? It will
Yes,
sort
sir.
it in the alphabetical order because there will be an order involved. It sorts the data. Sorting is definitely involved during the a cluster index choice, right? If you create
It
a
will.
cluster index on the test column 2, then it will sort it depending on the alphabetical order. Maybe A, B, C, D, the sequence will come, and then depending upon that, the sequence will be created. Let us try it out.
Depending
You are
on
asking, why don't we see it, right?
the.
Can we not do it? So how do I have created an index. How do I drop the index? I have the drop command. Drop index index name, table name dot index name. This is the syntax. Table name dot index name. This is the syntax of dropping the index. Drop index name. I drop the index. So if I go to the indexes, I did a refresh. There is no index left. Okay. Why don't I create a clustered index on the second column as you are requesting? Okay. Before also index, why don't I actually show you another thing? Okay, I dropped the index. Let me go back to my select query. Let's see whether something changes. Can you see? If I have ever created an index on a clustered index, SQL Server has sorted the data. Actually, the rows are there sparsely available inside the hard drive, right? But when I created the clustered index, it rearranged the data set. Even if I drop the data is now arranged, right? That is where even if I dropped the index, the existing data will be sorted. The new data may be in random order, but the existing data will be in a sorted manner. Okay. Clear about this particular point? Up to this point, let us insert 2 more rows because I wanted to insert entire team set, right? Let's see what happens. So if I go, I had 1 2 3 4 5 6. So my sixth down is, say for an example, is coming as who is the sixth down? I want to say, who are the recent players in the Indian squad? Let me find out.
Dinesh Karthik.
Dinesh Karthik, okay. Name some. Dinesh Karthik. Tell me 1 2 more. I have 7th and 8th pending. So 6th is coming here. 7, 8, 9, 10. Okay. So I will say 10th. Who will be my 10th? Who is the bowler? Tell me one bowler name.
Bumrah.
Jasprit Bumrah. And any other bowler? 9th down.
Harshal Patel.
Harshal Patel. Harshal Patel. Then 8th down. Maybe I will say 6th and I will 7th down here. Seventh, any batsman name? Who is the keeper? Any player?
Hardik
Dinesh
Pandya.
Karthik we have sent. Hardik Pandya, and one more player. So 6, 7. So there will be 9. I will say 8. One more player.
Ravindra Jadeja.
Ravindra Jadeja. Okay, done. I have my cricket team inserted now. Let us insert this 5 record. I'm again inserting them in a random order. See that. Okay. 6, 10, 9, 7, 8. Inserted. Now I will do the select star from table. There is no index available. See, these 5 were sorted automatically whenever I created them. Can you see that? After that, I inserted this record, all random order, no sorting happening. Okay. I also wanted to show you one thing. When you do the select star from table, what type of table it is? There is no index available in this table. What type of table it is? Student, if a table does not have a clustered index, what type of table it is?
Heap table.
Heap table. Do remember, if a table does not have a clustered index, it's a heap table. So I'm doing a select star from a heap table. Now I'm doing one operator. Write down this particular thing. I'm doing control plus L. Control L for lamp, L for leg. Control plus L. Okay, I'm doing that. Highlight the code and do the control and L. What would you do? Highlight the query and do control L. If you can't do that, if you are not able to see that, highlight the query, go to the view, go to the query, display estimated execution plan. Can you see that? In the title, go to the query window, go and select display estimated execution plan. It will say the same thing. Okay, table scan. Do remember, I don't have an index available. How the select query will fetch the data? It will go and fetch all the record one by one. It will go scan through all the record one by one, and it will fetch the data. Okay, this is execution plan. Means what? Execution plan means it is a hint from the SQL server how it is going to search the data for you. Clear about that? What I'm saying, I don't have an index, so if SQL server will do what? Look for the data in every page of the book. That is what it is going to do. That operation is known as the table scan operation. You don't have an index, it has to go scan every row by row. Done. Now I will create a clustered index on the on the column 2. I will create a clustered index on the column 2. Created. I'm going to search the data. I have a clustered index available now. Do remember, now the data is not sorted on my order. I have the clustered index on my column 2. Can you see the data is sorted depending upon the alphabetical order? D, H, H, J, K, M, R, S, V, V. Clear about that question, whoever has asked it? Kalyan, you are clear about that, right? If you want to create a clustered index on a variable character data, it will sort the data depending upon the alphabetical order. Correct? That is the pattern. Now I want to show you another behavior. You will highlight the code and say control L. Previous exercise was saying table scan. Now it is saying index scan. Is that understanding correct? Index scan means what? Now it will not go and search the data directly. It will go to the index page first to look for the data availability in the index page, find out where the data and the page number are available, and then go and fetch the data from the exact page numbers. Are you getting it? Now I want to write one more part to show you how the index pattern changes, where I will say my test column name is Sachin. I have a clustered index available on the column, test column, and I'm looking for the exact keyword Sachin. I could find the row. Now I will do the control L. Can you see the behavior say indexic? Okay. Do remember, this is also an interview question. If you do not have an index available on the table and you are writing a select star from the table, what type of
execution plan comes up. This particular thing is known as the execution plan. Answer is table scan operator will come up. If you have a clustered index defined on a column, but you are not using that clustered index, that means I am just writing the select star query, but I am not writing a where condition on that particular column. Then what type of execution plan will come up? Because I have created a clustered index, it will go for an index scan. Look for that. It is going for a clustered index scan. Can you see that? Logical approach. I have an index available. Now I can refer for the data in the index page first. Okay, so I'm going for the index scan. I have an index available on the test column, and I'm actually looking for the data by writing a where condition. What operator will come out? I have a clustered index available, so the operator will be clustered index seek. If I'm writing a query on the column on which my index is created. Okay, now let's see another behavior. I have a query, I'm selecting all the data, but I'm writing the code on my test column 1 rather. I want to say, tell me all the data where the test column 1's value is matching 12. It will get me a record for Venkatesh Prasad, correct? It is getting me a record for Venkatesh Prasad. Now, what will happen if I do the execution plan? It is, though I have a clustered index available, there will be a scan only. Can you see that? Why? Because my index is on test column 2. You are writing a where condition on test column 1. Do remember, if you have an index created on a column and you are using that particular column to apply the filter or a where condition, then your operator will become a seek operation. The seek operation is the best way of writing the select query. Scan operations are the worst way of writing the select query. Clear? Scan. Scan means be it a table scan, be it a index scan. Both are not good. If you are writing a query, that means you need to write a where condition appropriately to select what exact data that you are looking for, right? And when you are selecting your where condition, always try to have those column in as a part of the index so that the search query will be much more faster. Control L, index seek. Why? Test column 2 having an index and I'm looking for that particular column for my where condition. That's why index seek. I don't have a index on the test column 1 and I'm looking for that particular thing, but I do have clustered index. So rather than doing a scan on the table, I will scan on the index. That is what the operation is saying, clustered index scan. Okay, that is what the 3 operator that is coming out of this. Now, these are the basic thing that we have already seen. Now going back to the second category of index, that category is known as a non-clustered index. It is the similar behavior. I will go and create a non-clustered index on the table. Here I will create a non-clustered index on the table. Okay. Say for an example, I want to create a non-clustered index. I will say create non-clustered index name on column 3. Say for an example, I want to create a non-clustered index on column 3, and I will say column 3. Execute. Done. I have created a non-clustered index. That means it will have the key value pair. It will not alphabetically sort. It will not sort my data rows. First thing. Second thing, though I have an index available, it is not the exact data that is available in the clustered key, right? In the clustered, the data and the address of the data both will be stored somewhere. The data and the address of the data both will be stored. In the non-clustered index, only the address of the data will be stored. So whenever the search query happens, somebody looking for the record number whose name is Ravindra Jadeja, or somebody is looking for Jadeja, it will go and find out where is the probability of finding Jadeja in page number 25, page number 35, page number 49. So only the address is noted. So it will go and fetch the data from 25, 35, and 39. That is how the operation will be. And if I do a select star from the same table again, select star from the test table, where my test column 3 is the part of the index where test column 3 equals Jadeja. Then what type of operation will happen? It is a non-clustered index, so it will do a non-clustered seek. Let's see, or it will say index seek. Control L. It is saying clustered index scan. Still, it is saying clustered index scan. The reason being you are writing star. You are not only looking for test column 3, you are looking for test column 1 and 2, which is not covered in the part of the index. Okay. So if I will only say test column 3, I'm searching for test column 3 and looking for test column 3, then it will be index indexing operation. What will happen if I search for test column? Test call 1. Test call 1 does not have an index. Okay. I have an index on column 2 and column 3. Column 2 is the clustered, column 3 is the non-clustered. Test column 1 does not have an index. What type of operation will happen here? Still an index scan. Why? It will do a scan. Why? For the column 3, it will find the index. The value of Jadeja will be stored somewhere at least. But the test column 1 does not have an index. It doesn't have a address stored anywhere. That's why SQL Server decided, if I have to go and search for the test column 1, why don't I scan both the data? I will go and do the index scan on the clustered. I will use the clustered index map to look for the data and go to the data row and fetch it for you. That is where it actually chooses the clustered index scan over any other operator. Okay. What would have been better operation to do this? There is another operation I want to show you what you should do. I have a test column 3. I know that for this particular thing, I have an index created on a thing for the test column 3. Is that correct? You can see that. What I want to do, I will go to the properties, and I am seeing the test column 3 is the part of the column. I want to include one more column. While you are searching for the data, you also add one part of the test column 1 as part of the index also. I'm just including that particular column now into the clustered key. Now I will look for the data. Now test column 1 is also part of the same I index test column 3. Okay. Now if I do the search, doing the control L, now it is saying index seek. Previously it was saying clustered index scan. But what I did, I made sure that test column 1 is a part of test column 3 index. Okay. Now the search query is able to find the data using that particular index. Control L. If you see that, it will tell you which index it is referring to. If you see the object location here, come to the object location on the bottom, last 3 option from the bottom, seek predicate, output list, and the object. Object is saying it is referring the IX test table test column 3 index to fetch the data for you. That is what this particular definition is. Now I'm going into very detail and very depth of the index. I would say I will not, you shouldn't be worried about. I'm just talking about how this entire operation work. You should be worried about what is a clustered index, what is a non-clustered index, right? Non-clustered index doesn't sort the data, clustered index sorts the data. How many clustered index you can have? Only one clustered index you can have. How many non-clustered index you can have? As 999 columns, your index, non-clustered index you can have per table. Okay. How by default when you create a primary key, it creates a clustered index. By default when you create a unique key, it creates a non-clustered index. These are the basic definition you should remember. Now going back to my slide deck, I have given the example. I have written a lot of the concept that I was trying to explain, what exactly it works, how does it filter the data. I have given the example of the non-clustered search operation, how exactly it is doing. This we covered. Table scan, I have shown you how the table scan works. Yeah, I didn't show about the composite index, right? In case I want to create a non-clustered index on both the column, can I do that? This is what I want to create a composite index on a table, right? I want to create a composite index. See, there is an question. This is also an interview question. What is the simple index versus a composite index? Do remember, if you are creating an index on a single column, that is known as a simple index. If you are creating an index on a single column, that is a simple index. If you are creating a index on combining multiple column, that means it is a composite index. Here in this example, I am trying to create a non-clustered index on department table by combining the department number in the ascending order and department name in the descending order. I'm combining an index that is a combination of these two values. Can you see that? I'm saying you can create an index for me, please. It is a non-clustered index that I'm requesting you to create. And while you create, you sort my department number in the ascending order and department name in the descending order pattern. Okay, that is how I want you to create my non-clustered index. Okay. This is known as a non-clustered index, but it is a type of composite index. Why? Because it is more than one column. Also, do remember, while you are specifying your on clause and the column list, you have the option of specifying whether you want to sort your data in the ascending order or in the descending order. Okay, if you do not specify anything, it will be ascending. If you want to specify that my data has to be sorted in a descending order, you can specify while creating the index that you sort my data in the descending order. Clear about that particular approach now? Now, if I go to the, I have shown you how to delete the index, drop index name. I want to know about, tell me how many indexes are available on a table. There is a procedure available that you can pass sp underscore help index, pass the table name to that. Say for an example, I want to say department table. Tell me how many indexes are anything available in this. It will tell you what type of index available, what type of index it is, and what are the columns involved in that particular index. Okay, you want to know how many indexes available in this particular table, test table. SP help index, test table. How many indexes available and anything. Okay, this is one way of finding. There is another way of finding. This is another way of finding. Select name from, select star from sys indexes. IDX. Yeah, this is another way of finding the detail about the index. There is an metadata view available known as sys indexes. Whatever index is created within the SQL server will be captured here. All the indexes that we have available on our system will be captured in the sys indexes view, right? You can actually query the sys index view and pass where the index name is this. Tell me what is that particular index, what is the definition, is it a clustered, non-clustered, or a heap? Can you see? These are the three category of indexes you will find. Heap means a table that does not have a clustered index on them, right? So sys indexes view contain all the data about all the indexes available in the SQL server. Okay. Now I will move on. Delete index. Difference of the clustered index and non-clustered index is written here. This will physically sort the data. This will not arrange the rows physically. The operation is much more faster in the clustered index. Why? Because it is the very one column data type. The data is by default sorted for you. That is why the searching is much more faster. It indexes the data for the table. You can create only one index per table. I actually did not write one index per table. And here 999 indexes per table. Leaf node of the clustered index contains the table data. It contains the data. In the leaf node of the B tree, it contains the pointer to the data. Okay. Leaf node means what? This is the leaf node. This is the leaf node. The bottom grid is the leaf node. Okay. Leaf node contains the address of the data. In the clustered index, the leaf node contains the actual data root. The last node in the line item is the leaf node. These are known as the root nodes. Okay. In a B tree structure, in a clustered index, the leaf node contains the data. Leaf means the last node of the record contains the data. In a non-clustered index, the last node contains the address of the data. That is the only difference between them. I would encourage mug up this particular thing. If you are remembering the concept well, you are prepared well for one of your interview question for sure. One or two guaranteed question will come from the index segment. Guaranteed. Any interview will go, you will hit this particular question. Difference between clustered index, non-clustered. Difference hiddenly the question will be difference between primary key, unique key. When you say primary key, unique key, you will talk about clustered index, non-clustered. Interviewer will jump you to the clustered index, non-clustered. So how you want to drive your interview is up to you, right? By default, when you create a primary key, it is a clustered index. By default, when you create a unique key, it is a non-clustered. I have written down all the interview question around the thing. What is index we have covered, types of index we have covered, difference between clustered and non-clustered covered. What is the table scan? If doesn't have a index at all, then it is going for a table scan. What is the heap table? The table that does not have a clustered index is known as the heap table. Okay, and let us take a pause before going into the cursor to understand more if you have any question. Any question, team? I know it is a very heavy session. It is a very heavy session, but do remember why I went into the detailing for a detailing about the concept of the indexes. This indexing topic itself is a job segment known as performance tuning segment in data engineering. Okay, in SQL development, there are performance tuning engineer. If you go in Naukri or Monster and look for SQL Server or tuning experts, database tuning experts, SQL Server performance tuning experts. If you look for those kind of segment, you will see a lot of job openings inside only for the index jobs. Okay, this is very very technical and very detailed. So what I'm saying, for your career aspiration, you are either you are in the 0 to 3 range of experience range, where either you are trying to brush up your skill or you are looking for your job interviews, right? I would say you look for only this 5 area, but I have explained you well. How do you remember the thing? Remember, the books front side of the indexes are the clustered index. Books last side of the index pair are the non-clustered index. If you do not have any clustered index and non-clustered index in the book, then you have to go for a table scan. These are the 3 operations you should remember. Clear about that? You have any question before moving to the next topic? Tell me if you have any question. I will try to unmute yourself. Lokesh, you are good? I want to actually understand the concept. Everybody has understood. People are dropping off. Is it like they have dropped off because they are not able to understand, or you are there in the class? I don't understand. There were 12, now it is 7. Is there any parallel session running? Are you clear all? Kalyan, Guljar, Arshad, Lokesh, Manideep, Vijaya. No one in the class, but then they dropped off. That is interesting. Venkata, internet connectivity. So, were you not able to hear me? There were some issues in between. Internet connectivity issue. I didn't realize actually. I thought it is going well. But if so, you please go through the recording. No parallel session. Okay, fine. If everybody is clear, can we take only 2 minutes? I want to take a 2 minutes break, please. I just want to have a sip of water, and then we'll start a very simple topic about looping, and that is known as cursor, and then we'll close the class. There are only 5-6 slides, and then we can cover it up. Okay, just give me 2 minutes. I will just want to gulp some water. Okay. Back online. All ready? If you have taken a break, I will give you 1 minute break also. Just come back, because today I want to cover this particular topic so that we'll be good on track. Students, are you liking the topic? Are you getting the confidence about the SQL Server? Are you practicing well? You are able to write join queries. You are able to understand the concept well. You are practicing your interview questions well. I want to know the feel from your side. Are you confident enough? By far, whatever we have covered, DDL, DML, DQL, joins, subqueries, indexes, constants, how is the feel? Did you get confidence? Unless until you practice, you will not get confidence. Remembering the interview question is definitely going to help. Trust me, student. I don't know whether you believe it or not. After the session, like I said, when I say you can start appearing for the interview, you will land up in a job, guaranteed job. That is the trust I can show in that. And I want to also, I will not boast about it. Students who have trained from me, they take only 2 or 3 attempts to clear the interviews. So if you are thorough enough in my session, you are spending only that much of time. And the practice exercise I'm giving, if you are doing that, you are through for your SQL developer position only. Data engineering you are doing anyways, right? You can also crack SQL positions directly. Okay, so be patient, be thorough in the session. If you're not getting the concept, I would encourage again and again, go through the recording, ask question. In Slack also start posting question if you have any. I don't actually look at the Slack, but I will ask someone to post those questions offline so that I can actually answer it out. Okay. If everybody is back on the class, let's start with the new concept known as cursor. Okay. What is the cursor? Let's see. The new topic that we are going to cover now is known as cursors. So our today's topic were two chapters. This is a long session. We always go for a Saturday, Sunday long session. So typically our topic would be covering is cursor. Do you remember? Cursor is a database object that helps in looping through data records returned by a select query. What is a cursor? Cursor is an database object. Let me write it down the way I'm saying. I will say cursor is a database object that helps in looping through records returned by a select query. We'll see that how it is happening. Okay. What is a cursor? Cursor is a database object that helps in looping through records returned by a select query. Say for an example, you are written a query select star from the pet table. There are 93 rows, right? I want to loop through all the 93 rows one by one. When I say select star, it will give me all the record. I don't want to get all the record one go. I want to get one record one by one, right? How do I do that? If I have to traverse through each of the rows returned by a select query, I have a mechanism available in SQL Server known as cursor. Okay, what cursor does? SQL Server cursor helps in processing a result set one row at a time. Okay, the SQL Server cursor works this way. Just remember this particular operation and diagram. This diagram help you do the thing out well. Okay, what you will do, you will first declare a cursor. Declaring a cursor mean, I will actually go to the page so that I will talk about it. Okay, these are the 6 operations you will do to achieve this row by row traversal of a select queries record. Okay, what would you do? You will declare a cursor. Declare a cursor mean you will declare a select statement that you are naming that it is my cursor. This is the select query that whatever result this select query will return, I want to travel through one by one record of the select query, one row at a time. So your first step would be declare a cursor. Second statement, open cursor. Open cursor mean execute the select query that I defined in the cursor name. I'm giving a cursor name to hide a select query. This is the first statement does. What it does? Declare cursor mean I'm giving a cursor name to hide the underlying select query. Open the cursor name means execute the select query. Fetch next from the cursor into variable. That means whatever record is returned from the select query, fetch next. Fetch the next row. Go to the first row first. Okay. If the select query has ever returned a result, go next to the select query result. Whatever is the first row, go to that, get all the record value into a variable. I will explain that. This is the syntax. Do remember the fetch operation makes you go to the first row. Then you will say while at the rate phase status equal to 0. That means this is a system variable that answer if the fetch operation in the previous statement is successful or not. If there is no record, the fetch status will say non-zero value. If the fetch operation is successful, it will return a 0 value. Then you will say while fetch status equal to 0, begin and end. Within that, you will do some exercise. Once your operation is done, you will say close the cursor. You are going to tell SQL Server, I don't need the cursor anymore. Close cursor mean it is a marker to SQL Server. Please close the cursor. I don't need it. Deallocate the cursor means SQL Server, you have allocated certain memory for me to do this entire operation, right? You are storing this record in memory temporarily, right? For helping me travel through each of the record one by one. I am giving you an instruction. Please release that memory. When you are declaring this, when you are doing this open cursor, it open cursor mean it execute the select query. Whatever result the select query has given, it will store it on memory. Do remember where it stores? It stores it on your RAM, okay? If you do not use this deallocate, after a certain period of time, your memory will be full, your system will crash. If it is a server, if you do not do the deallocate operation, your memory will be full, your server will crash. Server will crash, why? Because you did not do the deallocate cursor. Deallocate cursor does what? It deallocates the allocated memory to store the temporary result returned by the select query in step 2, right? Cursors are potentially dangerous operation. You should avoid cursor. Why I am teaching it then? Do you remember in your day-to-day life, you would not write a cursor, but you should study it because it is an interview question. That is why you are studying it. Okay. You may be needing it at times. I will talk about what that particular time will be, but there are alternative path available for the cursor. What you can do in cursor, you can do it using loop also. I will show you that in tomorrow's session, but let us understand cursor to be thematic. Okay. Now, if I've understood that, let me give you an example of this particular cursor. Whatever I explained, I will do this particular exercise to show you what a cursor is. Okay. This is what the cursor look like. Okay. What I'm trying to do, just look for this particular thing. I'm declaring a few variable here. This is how you declare variable in in SQL Server. You say declare at the rate. I have shown this in a previous session also. Declare at the rate and a variable name and what type of variable you are trying to declare. I'm saying varchar max, which is potential dangerous. It is 2 GB. I want to store 300 character space. I will say product name is 300. Okay. Listing price is decimal. I don't know in the product table whether the listing price is decimal. Let me correct it out. Where is my columns? In the unit price, I would look for this particular variable, Control C, Control H, at the rate unit price, unit underscore price, replace all. Okay. And what type of value the unit price decimal? It is a decimal value it is saying. Okay. Product name is a varchar, product name is a varchar 50. I should say product name is a varchar 50. Okay. What I'm doing here, I'm declaring two variable, local variable known as product name and unit price, to hold the value of product name and unit price, these two column from the product table. Okay. I'm declaring this first part. This is the step one. Step one. I'm declaring declare local variable to hold values from each row. Okay, that is what I want to do. That is why I'm doing the step one. Step two. Sorry, Control Z. Step two. Declare a cursor to define select query. Okay, what you are saying, declare cursor name, cursor for the select query. This is the select query, right? I will execute the select query. I am getting 78 rows. These are 78 products available inside my SQL server. But when I execute the select query, I am getting all of them at one go. Can you see that? I'm getting all of them at one go. All the 75 8 are coming at one go. I want to travel through them one by one. Okay, that is what the purpose that I want to do. So I'm saying declare a name. I'm giving a name to this particular select query. What I'm giving the name, I'm saying declare cursor name is cursor product, and it is a cursor type of object I'm creating for the below given select query. This is what the syntax of declaring the cursor. What you would say, declare cursor name, declare variable name, data type. This is how you declare the variable in SQL Server. Declare variable name, data type. Declare variable name, data type is cursor. Then you will say for the select query. That is how you are doing. Declare a variable name, data type. You are saying you are declaring a cursor type of variable for the select query. That is what you are defining. You are just declaring a select query. It doesn't do anything. You are defining a cursor type of variable. Clear about that? Now, step 3. Whatever value you have declared for the cursor, that select query you are doing, I am saying open cursor. Open cursor means what? Execute the select query in select query in step 2. Open cursor means what? Execute the select query in step 2. This is the step 2. Execute this particular query. Okay. Step 4. Fetch the first row of select query. Okay. What you are saying? Fetch next from the cursor into the local variable that I have defined. What I'm saying, if the select query has returned result, what I'm trying to do, if the select query has returned result, I know I have written select product name and unit price. There are two things that you might find. If the first row is there, that means whatever value is there in the first row, you store these two value in these two local variable. These two values in these two local variable. Okay. Clear? What I'm saying, fetch next the cursor into the local variable. That means what? Move to the first row of the cursor, and whatever value is there for the product name and unit price, you store that in product name and unit price variable. Clear about that? You are getting two values. So you have declared two value and you are storing that particular value. Step 4 is done. Step 5. Verify if there is a row there is a row from retrieved from step 4. If your select query has returned any result, you are verifying. In step 5, what you are verifying, if your select query has returned any value from the previous query, that means if at all there is a row, the fetch status, this particular is the server variable. Okay, I want to talk about a few server variables that you will also understand. In SQL Server, there are a few server variable available. I want to know my server name. I will say select @ server name. What is my server name? It will give you the server name. Okay, this is the laptop SQL server name. I want to know, tell me what is the select. So do remember, in SQL Server, there are some variable that comes in the orange speed, and that is superseded with two @ right? A variable that is defined with two @ sign in SQL Server is known as the server variable. There is a server variable available known as fetch status, whose purpose is to verify if my previous fetch operation in the cursor operation is a successful operation or not. If it is a successful operation, then the value will become 0. Okay, that means while is a loop. We'll study about the while loop tomorrow, but I'm using the while loop without your realization. What I'm saying, while the previous row operation is successful, that means if the previous operation is here is successful, that means that all one row is available. You do loop through my record. Okay, what I'm trying to do, I'm trying to loop through my record. What I'm trying to do, I will say select product name, comma, unit price. Whatever value you have written from the previous row, you show me those values and display. I don't want to cast them. I just want to show the raw value. Okay. And then once I am there inside a loop, inside the loop, I'm there first time here. I have to move to the next time. So I will go to the next step. So I have to go to the next step. I have to say fetch next from the cursor into the local variable. That's the syntax. Fetch next from cursor into the local variable. So I'm saying go to the next line. Then I will go to the next line. Then I will go to the next line. Then I will reach the 78th line. When I go to the 78th line, the fetch next operation will happen. It will be in the 78th line. There is no further operation. So the fetch status will return -1. The loop will break. So I am doing the operation inside the loop that starting from the row number 2 till the row number 78, you loop through. Okay. I will do one for your benefit of understanding. I will say print loop count. I will do one thing. Just to show, I will declare another variable also. I will declare comma @ int. I will just, for your example sake, I will set the value of I. It is just for your example. It is not. It has nothing to do with our cursor example. Set I equals to 1. I'm declaring a variable value capital I. I'm setting the value of I equal to 1. And inside the loop, I will say print Control Shift U print @ I. Okay, I want to see how many times this cursor operation has happened. So I'm printing it. Print my value of I. But when you are printing the value of I, after that you do the set @I equals to @I plus 1. Okay, I will explain this what this operation will do. Okay, done. Once your cursor operation is done, you will ask SQL Server, please close the cursor because my operation is all complete within this loop. I have traveled through all my record set inside the select. Then I will go and close the cursor. Please close the cursor mean it is an instruction SQL Server. I am not going to use this record anymore. Deallocate cursor is an instruction to SQL Server. Clean up the memory allocated to store this temporary data. This 78 data is stored on memory. Please clean it up. Please destroy them. Okay, I don't need it anymore. Deallocate cursor is an instruction to that. Okay, so step 5 you have done it. Step 6. Instruction to SQL to say we don't need the cursor data. Okay, step 7 instruction to SQL to destroy spelling DEST, destroy the memory allocated for cursor. Okay, heavy session by far. You might have got it or not, I don't know, but we'll see it and you will see how simple it is. We have 7 steps to do it. First step, declare variable. Second step, declare the select query, name as cursor. Third step, open the cursor. Fourth step, you do the first time, go to the first row of the cursor. Step 5, verify if the last fetch operation is successful or not. And you continue doing it till you find rows. That is where you are looping through. While is a loop that actually does that. Okay, you will select whatever data you have retrieved in the first step, and then you move the cursor to the next row. I'm printing the value of the I. We'll see what the printf value I mean. And then I'm instructing SQL Server, I don't need it anymore. I'm instructing SQL Server, release the memory that you have allocated for the cursor. Okay. Now what I will do, I will go, I execute all the statement altogether. Can you see what happened now? How many records are coming? Now all of my records are coming as one result set. Can you see that? The cursor does what? The explanation that I was doing and talking since last 15-17 minutes was to show you that all the 72 rows of data, I am able to go one record at a time. Can you see that? This is how the cursor is moving. If you go into the message, can you see first time the I value was printed as 1. It is going to the second row. It is going to the third row. It is going to the fourth row. It is going to the fifth row. It is going to the sixth row. It traveled how many times? For all the 78 rows. On the 78 rows, it couldn't find any further row. So this particular value returned the value of fetch status as something else, right? So I want to print the fetch status also. Print I and print fetch status. Print fetch status. Okay. And also print some lines so that I understand what is happening, who is doing it. Okay. And then I will execute again one more time. For row by row operation completed, I will go to the messages. First time, fetch status is 0. This is the 0 is the fetch status. 2 is 0 is the fetch status. On the last line 78, no further record, fetch status become -1. While fetch status equal to 0, this is a condition I'm writing. When the variable returns a value of 0 only, you proceed further. This is how the while loop works. While a condition is true, then only you enter into the begin end block. This is how the while loop works. While loop works how? While a condition is true, then you go. If the condition is not true, then don't enter into the loop. That is how the while loop works. What I'm saying, while fetch status equal to 0, till you are getting the next result, you move on. Till you are getting the next result as 0, that means there is a row available, there is a row available, there is a row available. You go to the next row, continue. On the last line, the fetch status return -1. The loop breaks and automatically we moved out of the cursor from this block to this. Then the cursor code moved to the close cursor. I've instructed SQL Server. I don't need the cursor anymore because now you have leveraged this data to store inside my memory on my RAM on my PC. Please release it. So, and this is an instruction. Please clean my memory so that some other process can leverage it. These are the purpose of the cursor. Let us go back and take some question first because I want to talk about some interview question and then we can close. Clear about the cursor concept yet? So Kalyan is saying I am understanding the session, but I am facing trouble writing this writing subquery. Okay, Kalyan, I will do a doubt clearing session tomorrow for half an hour. We'll actually do some student, please come prepared with your question that you want to actually answer. Maybe in half an hour, how much I can answer, I will try to answer. But if you have any specific topic also you want to get some clarity, I will repeat that topic. Okay, Kalyan, I will help you get that particular. This remember me of creating and deleting the allocation of variable while studying in college. Who is this? Yeah, Kalyan. Okay. Okay. By far, did you understand the concept of cursor, student? Clear about what is the cursor is? Cursor is the way of iterating through each of the record written by the select query. Is that understanding now correct? When I said cursor is a database object that helps in iterating through or looping through records written by a select query. That is what a cursor is. Okay. Cursor. Let's go back to the cursor presentation. This is what the example. I will copy the same example one more time. Duplicate the slide. I have given the instruction here, so I will copy paste Control A, Control C, Alt Tab. Go here, Control A, Control V, and Control A. Remove bullets. Control A, paragraph. Okay, the complete code is written so that it is there in the slide deck as well. All step and the definition. What you do, what I was explaining is also written. Declare a local variable to store the data. Logic should be updated based upon your need. Declare cursor means what? You are declaring a cursor object through which you are going to write your select query. Everything that I was explaining is written here. Please read through. If you have understood, that is correct. If you have not understood, please read through. You will get some sense of it. I've given the exact explanation of each of the 7 steps, what you are doing. Okay. Explanation also I have completed. Declare again, declare statement, declare variable used to define your local, to hold the local data. Select query to initialize your specific value inside your select query. Declare cursor statement to define your select query within a variable. Open statement, open the cursor to begin data processing. That means execute the select query. Execute the select query. Okay. Fetch next, that means go to the first row of the item. While loop, to loop through all the data record. Begin end, the block for the looping. Data processing complete, your whatever logic you want to do, you will do it. Close statement, that means you are saying that I don't need the cursor anymore. Deallocate statement, destroy the cursor object. Okay, that is what the operation is. When to use, when there is a need that I have to go through each of the record one by one, and then I want to do some other processing on that data, then only we need it. Okay. There may be hundreds of situations. We'll actually study about it tomorrow, more about the use case for the cursor and the loops, and then you will understand what. I will not give the example right now, but hold on to the thought. Okay. Updating data across numerous table for a specific amount. That means, say for an example, you want to look for the value of chai, and then you want to identify how many people have bought the chai independently. That means you get the product name and look for the corresponding data in another table. You want to do that kind of exercise. You find out what is the product and look for that particular data in another table. Look for the product, look for that particular data in another table, right? If you want to do that kind of operation, looping construct is a better way, and cursor is a kind of looping construct. Do remember why you should, I am teaching you, but do remember, in interview you will find the question saying, right, when to use, and this is the interview question. These are the interview question. What is cursor? What are the disadvantage of cursor? What is the alternative to cursor? And then complete structure of a cursor. Complete complete syntax of a cursor. Entirely prepare yourself up. Okay. In real life, you will never write a cursor in your day-to-day job. In job, you will not do it. Okay. But in interview, you will definitely get this question. What is cursor? What is the disadvantage of cursor? And what is the alternative to cursor? Do remember, by far, understanding this particular problem, what did you understand? What is the problem of this cursor? Anybody, if you have thoroughly listened to my statement, did anybody make some sense? What is the disadvantage of a cursor? Anybody want to say something or write? Do you remember, the cursor is created on the memory? When you open the cursor, you are opening the cursor. You are giving an instruction to the SQL server, please execute the select query and store it on my RAM. Right? You are saying you store it on my RAM. If you forget to write this statement, last line, if you forget to do it, what will happen? The memory will not be cleaned. That means, say for an example, there are 1 million record. Here in this example, there are only 78 record written by my select query, which is still very bare minimum. It is not a data even, right? Think about a select query that is returning 1 million rows. All this data will be stored on my memory. That means in one go, 1 million rows coming means 2 GB gone. Say for an example, my memory is of 8 GB memory on my computer system. This select query is producing 2 GB worth of data or 1 GB worth of data one go. Okay. First time what I did, select query, I forgot to write my deallocate cursor. I forgot to write step number 7. So 1 GB memory wasted. The data is still lying there. Second time executed the cursor, 1 more GB gone. Seventh time I did the operation, 7 GB gone. Eighth time I did, 8 GB gone. Ninth time, my computer will be unresponsive because there is no memory left. Why? The cursor, somebody forgot to write the deallocate cursor statement. What happens? If you do not write the deallocate cursor, the memory is not cleaned. It actually stays on the memory. What happened? What is the issue with the memory? This particular problem, if you do not clean the memory, is known as memory leak. Memory leak, why it is known as memory leak? Because the memory is used, but it is not cleaned after your usage, right? Memory leak will happen. Once the memory leak will happen, what will happen? The server will crash because your 8 GB memory is all gone. Next time, the server will crash, the system will go into the hung state. You have to reboot. Your application will go down, correct? The problem with the cursor is this particular statement. If you forget to write the deallocate cursor, it will create the memory leak problem. That is the disadvantage of cursor. Okay, what is the disadvantage of cursor? Cursors might create, it is not always create, might create memory leak situation if you do forget to write the deallocate cursor. That is the interview question. Okay, complete structure of the cursor, right? This is the complete structure of the cursor, 7 step. Next part. What is the alternative to the cursor? We'll understand the alternative to the cursor tomorrow, but the alternative is written also here. While loop. While loop is an alternative to the cursor. Do remember the answer is alternative to the cursor is a while loop. Okay, we'll understand a while loop tomorrow. So hold on to that particular thought. I will again reiterate what is the difference between cursor and the while loops. Okay, any questions by far? Sai Vijaya, you want to speak? Unmute yourself, please. Oh, sorry, I'm also doing it. You please unmute yourself, please.
Sir, I have question like after installing the SQL in my computer, I am actually doing all the processings, but recently I'm understanding that I have completely I'm having 70 GB of space already. But whenever the time I'm opening the SQL server and all, I'm actually losing 20-30 GBs of data continuously.
SQL
I
actually
don't
kills
know.
lot of, no, it is say it is not going to take 20 GB for sure. It will never take a 20 GB. Did you install the developer edition or did
I
you
think
install a
developer
different edition?
edition. Yes, sir. Yes, sir.
Developer doesn't take that much. It may be something else. Okay. It may be
Okay.
something else. Did you install a
Uh,
lot of data on your machine?
to some extent, yes, sir. Like
How
in
much
Visual
data?
Studio,
Okay.
uh,
Why are you talking about Visual Studio, Vijay?
in that software, I have installed nearly 6 GB of something space. It was taking.
That is
Uh,
fine.
it-
I wanted to tell you one thing. SQL Server doesn't take that much, but SQL Server is a heavy process. When SQL Server runs, when it is running right now, SQL Server, say for an example, on my machine it is running, it will take 20 to 30% of your total storage and the CPU cycle. That is why it is known as the
yes, sir.
server. It is meant to take it. But what is the problem with that? You are studying, no? How does it matter?
Like within 1 or 2 days, it is actually taking 2 to 3 GB of data. By the time, whenever I restart my computer, it is actually killing 2 GB or 3 GB continuously. Like within 1 week, I have lost nearly like 60 GB of space. I don't know. I have removed many softwares in my computer. Again, I'm having the same
I
issue.
don't
Like
think actually, no, Vijaya, it is not the issue with the SQL Server. Trust me, it is not issue with SQL Server. There is something else happening on your machine. Please show
okay,
it to someone. SQL Server will not take that much. SQL Server,
okay,
once loaded, will take hardly 5 to 6 GB of your total data space. That's all. If you're
okay,
losing something else, check for some virus or some other activity. It is not SQL Server.
okay, sir.
Okay.
Sure, sir.
While running, it may spike, but after your usage is down, your SQL Server usage will come down. Okay.
Okay, okay.
There is a question from Sasi Pritam. Sasi Pritam, please unmute yourself and speak. Uh, Sasi, unmute yourself. Sasi Pritam. You have any question? No question, sir. Okay. Anyone else? Kalyan, you have a question? Please unmute yourself and speak. Any question, Kalyan? Okay, fine. Did you get the concept of the cursor and the indexes? These today, whatever we have studied is our interviewer favorites. Do remember, any interview will go, these questions will come, and you know the answers now. So prepare yourself enough so that you are ready with all your interview and question. And you want to validate yourself, go and appear for any SQL interviews, wherever it is happening, so that you come to know about whatever you are studying in the class, how much you are ready by now. Okay. So practice well enough. Today I will give you some examples for the cursors and there is nothing, no exercise can be given around the indexes. So I will give you 1-2 exercise for the cursor. But did you attempt all the 75 odd question that I have given in the select queries? Everybody. If you have not, then what question you couldn't attempt, right? Write down in Slack. I will look through them. Okay. Let's take a pause here. We'll talk more about the loops, ifs, if condition, and much interesting factors starting tomorrow. Take care. Bye bye.